So InsaneFX, this is my hobby project. I've been working on it for a couple of years. It sort of moves pretty slowly. Sometimes it moves rapidly, and when I have the motivation. So I just do it in my spare time. This nice little graphic was done for me by an artist that I'm working with in the UK, on and off. He's helping me test it and giving me ideas and features, requests. So what is it? It's an editor and a runtime system for basically special effects. So this is something I've done time and again for pretty much every company I've worked for, I think. And there have been times when I was sort of sick of doing it, and times when I really enjoyed it. But I decided to take some time out from doing this kind of thing for actually a living and actually try and make something that wasn't constrained by deadlines. So if anyone's new to this kind of stuff and they don't know what this is, I mean, any kind of special effects you see in games, basically like smoke and water and fire and what else? Fireworks. Loads of different things can be done by particle systems. And at the moment, InsaneFX does particle systems, and in the future, I'm hoping it's going to be able to do a lot more. So this actual presentation is going to be a live demo. I'm not sure how long that's going to be, and then it's going to be like a sort of a technical talk, sort of going over the internals, some of the internal data structures, and then I'm going to show basically how you would integrate the API into your game. So it's pretty technical. It's mostly orientated towards programmers. Is everyone a programmer? Are you? Yep. Cool. Where's Tom? Spanish. Anyway, so the editor basically is pretty much intended for technical artists and designers. I have trouble getting anything to look good as a programmer, so yeah. The runtime is a C++ software component that you will integrate into your engine, and it actually simulates the effects that will get created in the editor. The compiler is basically the kind of the bridge between, so it takes the output of the editor and compiles it into an optimized binary format. Hello? So yeah, just to recap, I've only looked at one slide so far. This presentation is on InsaneFX, which is my hobby project, and it's a special effects editing and simulation environment. The three main components are the editor, which is for actually designing the effects, the runtime, which is a software component that will integrate into your game to actually simulate the effects, and the compiler is the bridge between them. So it will take the output of the editor and compile it into an optimized sort of binary format. It will load up in your engine. What is going on? I've got to turn it off. There you go. So basically, as well as I said before, that this is more of a technical talk. Well, I'll be showing a demo of how you use the editor as well. So if you're not a programmer, a few things might go over your head. A lot of the experienced guys will just sort of implicitly know a lot of the stuff I'm talking about anyway, but if there's something that you need to know, just interrupt. So, why something new? I like working with effects, and I wanted to make something, and eventually, that sort of coalesced into something that other people might be able to use. So I decided I was going to contribute it back to the community. I didn't think there was going to be much, to be made out of selling it or trying to sell it. So I've open sourced it, and hoping to get other people involved as well in working on it and using it. Also, obviously, I thought I could do a better job. That remains to be seen. But I think I've done a better job than any of the other open source ones, at least. Even though it's disclaimer, it's not yet finished.
What license?
It's a new BSD style license, I think, from memory. So I started off with a philosophy that I sort of built over time. The first thing was that it was going to be driven by the tools, and the tools were going to get written first, and at least initially, like the rest of it, it would all be driven by the tools, and they would be easy and intuitive to use. I want to go for flexibility and power in the use of the editor, and worry about performance later. But ultimately, I didn't want to have a runtime that was really, really slow. So I want to work out a way to get, a high-performance runtime basically that sort of doesn't really detract from what you can do in the editor. One of the core concepts is you only pay for what you use. So if you're only using simple particle systems, for simple platforms, then you should get at least comparable performance to, like a hand-coded particle system algorithm. And the last thing is basically the renderer is to be implemented by the user. Now, where it stands at the moment, I've written an OpenGL and DirectX example renderers, but I haven't really concentrated on them, so they're really unoptimized. They do one draw per particle, so the rendering side of things is pretty slow, but like the way I intend it to be used is that you will integrate it with your existing renderer, your existing game engine, and you will take the geometry that InsaneFX generates and actually render that yourself. Ultimately, I do plan to release some optimized renderers, but still the intention is that I don't want to force anyone down a particular rendering path. So this is live demo now. So this is like the welcome screen. There's a few kind of resources there, simple documents and stuff to get people started. There's also a built-in tutorial.
So what kind of interface did you use for making all the graphics?
This application is written in C# using WPF. That's actually a slide later, so I'll talk about a bit more about that later. And WPF is probably a whole presentation in itself. If anyone's interested in that, I could do that as a separate presentation at some point. It does make developing applications like this easier, but only once you're over the learning curve. So this looks much better when you've got it on a bigger screen, like multiple monitors, because all the tabs and stuff here, you can drag them out and place them where you want. Try and get myself a little bit more space to work in here. So I've just created a new effect, and it really depends on where you want to start, but there's these kind of starting point modes here: billboard emitter, particle trail, and triangle. Usually good to start off with the billboard because then you get something visual straight away. We'll drag out the texture input node and assign a texture. Usually you're going to want to set some material state on it to get the transparencies and stuff. It's only got a really simple material system at the moment. So you can't really do much with that by itself. I mean, there's a few things you can configure there, like the width and the scale of it, and its rotation and colour and opacity and all that kind of stuff you would expect of a billboard. You can actually change the variables here in this attribute editor. So you can do some basic stuff there. Don't worry about animations in here. To do anything with it though, this is just kind of like a static object in the scene now. It doesn't have a lifetime or anything like that, or any physics associated with it. To do that, you need to sort of make it a child of a particle. And with a particle, you can set lifetime and its position and direction and speed. There's a couple of simple behaviours for it. And to actually get these things like being produced by an emitter, you want to put down an emitter there. So already we've got something. So a continuous stream of particles using all the defaults of the emitter basically. So you can play around with some stuff here in the attribute editor. speed and the rate at which they're coming out. The real fun stuff comes when you actually want to make, when you want to drag out some of these and actually do something like a data spread. So with the spread, basically, you can set the inner and outer angle. You can edit the kind of static variables here, or you can drag them out if you want to get randomized values. The spread's already randomized internally anyway, but it just shows you how to use a random number. I'll just get rid of that anyway. So make it, just make it a little bit tighter there. Now, it's meant to be pretty orthogonal, so you can do things like have an emitter under another particle and put another emitter on the top of that. You can do some interesting things here.
So each particle is emitting its own particles.
You can build up sort of recursive effects and stuff pretty quickly. And like it's just one of those things that if you put it in the hands of an artist, they'll instantly make a billion particle system and blow up. But they'll find some really interesting ways, really complicated ways of using it and doing things you just never thought of. Just from a few simple things. Of course, you can do all sorts of animations as well. So usually opacity is one that you want to do. So you choose a number animation. And basically just sort of build a curve. It doesn't do any kind of nice real curves, it's all sort of linear animation. But as you can see, they're fading out now. Is that obvious up there? You can do the same sort of thing with scale.
Describe when you make the emitter a particle and then you put that through an emitter. Describe what that did.
So I've just put a scale animation on it. So what was your question? When I put a particle,
Made the emitter the particle itself, didn't you?
yeah.
And then you put that through an emitter. What does that do?
So basically, each particle can have children, and that can be at the moment that can really only be billboards, emitters, and other particles. In the future, I want to support meshes and maybe some procedural geometry. But effectively, that sort of creates a little mini scene graph under that particle.
So does that mean each particle is also emitting its own particles?
Each, yeah. So each particle has an emitter attached. So you've got this like root emitter. That's you can see here it's periodic. There's a couple of different types of emitters. It's periodic, and so basically this is the template for the particles it's creating. And when it creates it, it automatically has an emitter as a child, which is also periodic. The whole effect is going to change quite drastically if I change this to a burst emitter. Presumably if I change this to a burst emitter as well. Because all the emission happens right at the start, whereas with the periodic emitters, it's happening continuously. I might get rid of that scale animation because it's sort of obscuring the next thing I want to show, which is trails. So that's another thing that could be a shoulder particle. This trail.
C-scale.
a lot of time managing the graph there. I wonder, is there any better way to represent this relationship?
I often wonder that myself, but this approach, it's one that artists tend to like. They're used to doing that kind of thing, this kind of thing in mind.
Nice idea might be kind of programmatic interface.
Yeah, I've considered that as well. So that's pretty cool texture on that. I don't actually have any good trail textures, so I'm just going to use a particle texture.
So they're leaving a trail of particle behind them, is that right?
Which is weird. I might get rid of one of these. You need to put some opacity, some transparency on that. I might make this spread a bit bigger, just so I can see them.
Yeah, one day.
So a lot of material to the trail.
So how is a trail different than just tapping an emitter on a particle with just dots, particles, whatever else?
Yeah, basically a trail is basically just, at least in concept, a specialised kind of emitter. And originally, in the original plan I had, it was just a different kind of emitter. But the artists I sort of tested it on had their sort of, originally even, there were different nodes, different emitters, and there was a lot more sort of granular things that you could sort of combine together in different ways. But it was just, it was a little bit too difficult to get into. So you might want to have some opacity on that trail as well. Give it an animation. So we can see it, I might cut down the number of things that are being emitted. So this top preview window here basically is previewing the entire effect always, and the lower preview window there basically just previews the kind of one thing that you've got selected. So you can sort of navigate your way around the effect subcomponents. There's also features for making presets, so taking parts of your graph basically and collapsing them. It's a way of organising as well, so you can make entire effects into one node, and then you can sort of copy that off and drag it back. Get it down to that. There's like an overview window here that basically gives you a way of navigating the entire effect quickly. And then these are all the actual nodes that you can drag and drop. But pretty much all of these are sort of contextually available when you drag out one of these inputs. You've also got a texture library here. So again, that's contextual if you drag out the texture input. You can switch from, hopefully fingers crossed this will actually work. So you can switch between OpenGL and DirectX at one time. And there's an external preview. So a little test app. Cool. So, any questions about that before I move on?
You thought of having trails as actual strips rather than individual billboards?
They're not individual billboards, they are actually strips. Let's see if I can remember how to turn on the... They just look like individual billboards because of the texture I've used.
Oh, yeah.
That's repeating texture.
So you can see that they're triangle strips in that hopefully.
Do they sort of billboard strips?
Yeah,
So it's like a line that's
yeah.
Have you got any way in your editor to move your emitter? Because that's one, by having done these before, that's what I've always found is that they look differently to something.
There's a couple of different ways of doing that. There's a game input node, which basically can be like a float or a color or a matrix or something like that, which you can name, and then you can, through the API, you can actually plug values into that. Kind of the way you'd set values on like a DirectX effect. And there's also an instance of effect has a concept of having a position. So there's an API function for actually setting the position of the effect in the world that everything else in that effect will be relative to.
If you wanted to do like smoke from a train, you want to see what it looks like when the train's moving.
Yeah. So in that case, basically, you want to have an input that's kind of like the smokestack for the train, and basically update that once per frame, probably. Rather than say translating the entire effect in world space. There's also an effect browser. There's not much to see at the moment except my a whole bunch of example effects that are pretty basic tests of some of the features.
Try ripping some effects from virtual games just for test purposes, like exposure.
No, not yet. I should do that. So, just want to a couple of slides on basically on performance because there's probably lots of questions you got about that. But I mean, the editor, as you've seen, is pretty flexible. You can do a lot with it. And the real question was, how do you actually get this level of flexibility in the engine, in the runtime? And the answer I came up with was bytecode after considering a couple of different possibilities. Because, as I said, I did the tools first, and I worried about how to actually do it any time later. Would bytecode basically have good enough performance? So that's a question you're all going to ask. And originally, before I started doing any of this, I was sort of experimenting with doing effects in Lua and Python, and that's quite fun to have a play around with. You can do some simple stuff. You do soon run out of performance, as you might guess. So I sort of moved on to the idea of making my own scripting language for it. I probably bit of more than I can chew. It's taken a long time to actually, get this to a workable level, and there's still some big internal changes that I want to make to it. But I consider making my own scripting language so that I could actually design it for effects and have the bytecode be like high level. So there's for example, there's one bytecode instruction that does physics evaluation if you have particle with physics enabled, that kind of thing. Make it data cache friendly and basically optimized to hell. In fact, it was Darren that gave me a name for the data cache stuff, the data-driven orientation.
Oh, yeah, it is though.
Yeah, which is really cool. And I've got a graph from that, I think, on the next slide. Oh, the next slide after this, actually. So did it work? Well, it's still a work in progress. I'm pretty happy with it so far. I haven't given up on it. I can, even this with my shitty renderer, that's like one draw per particle, I can get 40,000 particles on screen at once with some simple physics and gravity and stuff like that. Each entity is, when I say an entity, I'll say that's basically a particle. Each entity is about 64 to 180 bytes, including overhead filters and stuff like that. And so that's sort of the only pay for what you use philosophy. Like if you only have one particle with one billboard and simple physics and a simple color animation, it's not going to use that much. It's not going to use that much performance.
You use CPU limited?
Sorry?
When you're getting 40,000, is it CPU limited or GPU?
It would probably be GPU limited at that point, but I didn't want to test that. I do have a separate performance test set up that's completely independent of the renderer. and that's where I basically, because the renderer is sort of plugged into the runtime, and so if you don't plug anything in, it just doesn't render anything. And so I can basically run the update and run all the geometry generation stuff independently of having a renderer, and I do performance tests on that, which is basically, it's how I've been optimizing it today, because I'm not ready to optimize the renderer yet. So there's still a fair bit of optimization work to be done. Time will tell whether it'll be successful, whether people use it. I'm having fun making it anyway. So this is a graph that's sort of going around the internet a bit, which I quite like. Basically, designing your data for the data cache is like more important than ever before, and it was always sort of important in the old days working on consoles, but you might think it was going away, but it's not, because like, as you can see by this graph, CPUs are getting like faster, quicker than the performance is improving in memory. So actually having like optimal data formats and designing for the data rather than the code is continuing to become more important. And that's a whole other interesting presentation for itself. So this is a system overview of InsaneFX. Over on this side you've got the editor. And it basically works with SFX files, which is basically like a text file representation of exactly what you see in the graph. So that's what it saves, loads when you create a new file, that kind of thing. It exports to a format which I've called FX script format, and it's a text file format that could be used. Even if you chopped off the editor, the rest of the system's kind of usable, because you can hand code in effect using this simple language, and I'll show you an example of that shortly. On the actual kind of asset pipeline and game side of things, I've got it broken up into two sections. The top section is where you have your asset pipeline, and you use the command line FX compiler basically to convert your FX script files into this RFX format, which is the binary file format. And then the InsaneFX runtime basically can load these RFX files into memory from files, and it will, the bytecode for the system is contained in these files, and it runs the bytecode, and the bytecode generates geometry basically that's pushed to the renderer. The other configuration is basically good for prototyping, and basically what I do in the previewer is to have the FX compiler library kind of built into the application, and so it can load directly from FX script files and then basically compile them in memory into the binary format and then run from that. Calcu.com, by the way, is really good. You can sign up for free, and you get about 25 free diagrams you can hold in this system. I've been using it for a couple of years. It's really good. I'm tempted to pay for it actually, so we get the diagrams. So I'll talk a bit about the editor before I get onto more of the internals of the actual runtime. So you see it's, you build an effect using a node graph, and it exports to this FX script format, which we'll look at in a minute. And as I said before, I use C#, WPF, and the design pattern that they call MVVM, which is model view model, which is like a modern evolution of this old MVC model view controller. It's pretty cool though, and the WPF API is pretty much designed with that in mind. So you can keep your UI and your actual UI logic completely separate. It has a steep learning curve. Like I started using it the wrong way. I started using it not with MVVM, and I slowly figured out how to use that. And because I don't think I'd ever really used MVC properly in the past, so I didn't have that background either. I can say though that once you pass the learning curve, it's a lot easier to make clean UI code, and it's pretty easy to get nice looking graphical applications. Like I think InsaneFX looks pretty nice for something that was skinned by programming. I did that myself. The only problem is WPF is not portable, and probably in about the last year I've sort of been wanting to get it to other platforms, or maybe deliver it in some sort of online format. but maybe that'll happen at some point in the future. C#, I should say, is portable. It runs on Macintosh, it runs on Linux, like here the Mono project, which allows you to have a self-contained executable that will run without having to install any kind of interpreter on the platform. But unfortunately, they're not going to support WPF, is it? I think just because it's too complicated. It's too big a framework.
How's your learning resources skilling with that? Yeah.
I read 2 books by Charles Petzold. One was just on WPF normal 2D applications, and one was on the WPF 3D, which originally I was thinking of maybe using WPF 3D to do some of the article stuff, but it turned out to be not great for real-time stuff. But it's cool if you've got like, it's easy to put together like a 3D UI using it, as long as it's not going to be real-time, which goes you want to use DirectX or something. After that, I learned more by reading some articles on Code Project. There was a good book called WPF Unleashed. It was pretty good. The company I was working for had that book already at the company. And yeah, I read some articles on Code Project as well. So it's part of the learning. I was doing a bit of writing about it.
I asked just learning using C# and WinForms, but
yeah, I really like it. I wouldn't go back if I had the choice, but you know, WinForms is, if you're doing simple apps where you just want to knock out a simple app really quickly, you want to stick with WinForms, you know, rather than actually going there to learn WPF. But if you want to make an application, you know, that's a big complicated application, WPF is good because it'll allow you to sort of separate out the components of your UI and do unit testing on it, and it's just a nice way of organising your application, and also the kind of the skinning aspects of it will allow you to make it look pretty at a later stage as well. Not really. I do have like a barrage of tests, but I'll get to that. So the editor has internal and external preview. I'll show you both of those. Originally, the internal preview was written in C# and was using managed DirectX, and I converted that over basically to native. Really, just because I didn't want the maintenance headache of having 2 different renderers to maintain in my spare time. Because the performance was pretty good actually of the C# renderer, and it wasn't. I didn't even do anything special to optimize it. But I would have pushed it to its limits by now. But I ditched that a while back. So basically, the internal embedded previewer is the C++ runtime and the example renderers, basically packaged up in a managed DLL that I then include from the C# application. The external previewer is just completely a C++ Windows application, and it's a pretty good example. I mean, it's a complicated example because it's got a lot of features now to do with editing and debugging and testing and stuff like that. And I do include, like in the download, some simpler samples. The FX script language is the language basically that will interface between the editor and the runtime. It's what you might call an instantiation language. I'm going to give you a look at that now.
So it's the editor outputting scripting language.
Yeah. So, I mean, the idea is that the editor and the runtime are fairly well separated, and hopefully can potentially evolve in separate directions if they need to. Okay. So basically, this format is a little bit Lua inspired, just a little bit, because originally I was using like Lua for like data files and stuff. At the top level, you're defining your effect. Underneath that, actually, I'll just see if I can turn on some code filing. Yeah. Hopefully this will work. So basically, at the top, we've got a periodic emitter. It's qualified as 3D rather than 2D effect. In fact, the main people that have been helping me with this are using it for 2D games. So a lot of the work I've been doing has been tailored to them. So you've got all the attributes here, like the rate of emission, the emission direction, which is sort of a complicated expression itself. This is sort of what I call an entity expression, because this whole thing defines a periodic emitter entity, and this defines a spread entity. But it's actually something that's more analogous to like a function call, we're calling a spread function, and giving it the values. But these can be nested arbitrarily deeply. So you could have a ran function for that, which is a particular function that's there, or actually make another thing here that's going to be like a wave or something like that, and I'll give it the minimum and maximum values and the frequency of the wave, and that'll be basically an animation that's running to actually compute that value at runtime. There's actually a special format for animations as well, which I'll put an example in here. This property here is the actual template for the particle. And so we're defining the particle entity here and whether it's infinite and what its lifetime is. And then basically nested onto that is a billboard. That's how we do a colour. Actually, there's no examples of animation in this one, so I'll see if I can pull out one of my other ones. As an example of that. This is going to be a big one. Yeah, it's got no animation there straight away. So this is like basically a linear animation plugin that's edited within that interface I showed you in the editor. So you can build up simple kind of linear animations within here. And it's actually, to show that it's actually an expression, there's a multiplied by 3 on the end there. But it's this little thing here, that's the syntactic sort of opener for animation, the at symbol. There's one there for opacity. And basically at the moment it just works on 0 to 100%. So like this keyframe here is at 86% of the lifetime of that particle. And here we're setting the texture, and here the material. You see for this burst emitter, we're using a sphere with a particular radius to define its emission area. So this doesn't just have to be a constant, right? That can be an animation. It could be a random number.
How much work have you had to do on the compiler side? Like, have you gone as far as stuff like constant folding, like that times 5? Will that be done at compile time or runtime?
There is some constant folding, so a lot of that will get taken out. Well, not actually. It doesn't do constant folding into an animation. It's not that intelligent. I did about 2 months ago. I did a major refactor of the compiler, basically to simplify how it works, and hopefully that will allow me to make more sort of intelligent optimizations. That's what I said. It's that's what I call an instantiation language. So it's a language for basically instantiating objects, such as billboards, or specifying templates on how to instantiate them. And the kind of expressions you supply here that are basically executable code. So this defines an animation. The system will know that needs to be evaluated once per update. But certain parts of it, say that part of it, can possibly be moved to the initialization of it, rather than being evaluated every update. There's a thing there basically that applies friction to that particular particle. There's one for acceleration as well, which we use to These are what I call, in the editor, what I call behaviours. So there's only 2 at the moment. There's only gravity, or acceleration, and friction. But in the future I want to do more, like collision and some other interesting stuff like that. I'm going to talk more about the compiler in a minute. And how it works.
So one question. This seems to be all about visual effects, but some effect systems I've seen recently really just open it up to be effect scripts or effect editing where you can put in sound, field of view changes.
Like I said, I would like it to be more than just particle systems. I'd like to incorporate shaders into it. I never really thought of sound effects, but maybe that's an option as well. Definitely changing, your camera settings and stuff like that is really important to be able to do as an effect when you go. Just locks the camera or something. I would think that would be some sort of call back into the render, tell the render to do something, or give it a particular modification for camera settings. So the compiler is a C++ command line tool. Basically, it just encapsulates a compiler library so that you can use it from within your application. It takes an FX script file format and has a fairly simple recursive descent parser that's based on a grammar that I've spec'd out as part of the download. It turns that into an abstract syntax tree. Basically, the bytecode generator works from the abstract syntax tree. And this is the thing that's kind of, I've completely refactored this recently. I was hoping to use some kind of automated approach like Lex or Yak, but I had a bit of trouble actually, trying to get that to meet my custom needs, which are basically to be able to split code out between the initialization, the update, and the render. And making these other tools do that was difficult. So in the end I went for completely rewriting it as a hand-coded solution.
There's some more licensing stuff that you can Lex and Yak as well.
Probably. It probably would affect my license. So basically the generator uses this bytecode emitter as well to basically output the RFX file. That's pretty simple. There's a lot of code there, but all the principles that are in that are pretty well known. No, I would like to one day. But yeah, there is the option of, if I can't get ultra performance out of running this bytecode, there is the option of actually using something like LVM to actually compile it into native code, like just in time, something like that, in which you get the full advantage of having like a native.
You can even use it to output your bytecode, like you would out the bytecode as back end, and your language as a front end. You've got already a difference being you can swap out the back end. That's if it sort of goes to the middle.
Sounds like you want to do a presentation on it in the future. This is an overview of runtime. This is like pretty much just a schematic view. It's not really indicative of how things are laid out in memory or anything. At the root of the whole thing, you've got like your FX engine, and that is the runtime. And if you need to, I don't know why you would, but you could have multiple engines instantiated, and they don't like interfere with each other or anything. In any particular engine, you can have your effect templates loaded in, and these are basically just the RFX files loaded into memory. Every effect template can contain multiple entity templates. So, like a particle is a special kind of entity. Now you'll actually create instances of your effects from the templates, and these are the things that actually manage all the runtime data and have a position in world space, that kind of thing. Each effects instance can have like multiple entity instances, and these are basically the particles. So if you've got an effect with loads of particles, then you'll have loads of entities.
Is that like a shared pool, or do they each have their own?
I'm coming up to the memory allocation in a minute. So you've got the bytecode interpreter, which basically executes the bytecode for the effect and each of the entities. And it outputs geometry to this intermediate geometry buffer, and it's the geometry buffer that's passed to the renderer to actually be rendered. this is like sort of a, this diagram is supposed to kind of represent how it looks in memory. So basically at the root you've got your effect instance, and the particular problem I had was that because each type of entity can be different, because, you know, like one entity might have 2 billboards, another one might have 3, you know, in the future an entity might have like a mesh attached to it, you know, they might have different types of emitters, and the thing that defines the differences is the bytecode. And the size of each entity can be different as well, because depending on how many animations you're using and how many kind of intermediate calculations it needs to store per entity, each entity is going to have a different size. And so to make this work, basically, each effect instance compiled into the actual data structure for it is an array of buckets with basically pointers to linked lists for the different types of entities. So these might be the ones, you know, with 1 billboard, these might be the ones that have 2 billboards and an emitter. So we've got these linked lists of blocks. One linked list for each entity type. Just pretend that there's some more here, or maybe they're just null pointers or something. And this is basically like one block exploded out. And so each block is basically an array of entities, or to put it like in kind of more sort of game engine language, an array of particles. This is completely configurable, how big each block is by the application. So the number of things that are in here isn't really indicative of what it actually is, because that's up to you as a user of it. It gets more complicated than this though, because I support hierarchies. And so if you take one of those blocks before and you like expand out and enter the instance, and this is meant to indicate the memory that's, you know, the runtime memory for one instance, it can basically have its own children. The first thing is, at the start of each thing, is the entity instance trunk. And basically that just is a C++ structure with an arbitrary amount of data tacked onto the end of it, you know, depending on what you wanted to do with it in the editor. You have this kind of one thing that basically is, it's actually, these are like baked into it, these blocks. They're not kind of a separate array or anything like that, but they're what I call the dynamic children. They're like the kind of the sub-hierarchy underneath a particular particle that can be changed. There's entity storage, so there's a block of sort of memory here that can have different sizes depending on what you've done in the scripting language or in the editor. And so basically it's just, it's recursive in this nature that, you know, these are the different types, because there's a bucket for each different type of entity, and for each different type there's a linked list of blocks, and each block is, you know, the children. And it can recurse down again, but it wouldn't be difficult to make an effect that did that. For example, like an example of this is when you've got, there's a flag on the emitter that's called local space, and basically any particles that the emitter creates basically as children of the emitter, as a hierarchy within its local space. So that if the emitter is moved, then the emitter is whatever, and then all its children are basically translated in space with it. Now there's another way of doing hierarchies as well. Basically because if you've got like a hierarchy where you've got one thing and you've got like a child of that, and it's only one child, it's not going to be like, you know, multiple children. I've got a way of basically baking in particles. And basically it's what I call inline children. So this kind of last chunk here of the entity is itself potentially an array of static kind of subparticles that are baked into it. And an example of this is, one thing you can do in the editor is you can have a particle as a child of another particle, and for example you might want to make the particle like have an orbit animation. So wherever its parent particle goes, this subparticle is like orbiting it. And because it's only one particle and there's no emitter involved, and there's never going to be more than one particle, it's basically just baked in. And that's the only case, that's actually the only case where this is used, because in the cases where you see like a billboard as a child of a particle. That billboard is like completely baked into the bytecode and indistinguishable from the parent entity anyway. So it effectively disappears from the structure and becomes part of the same thing. But when you have a separate particle as a child, you need to maintain this kind of hierarchical data structure so that you can actually generate, traverse the tree and generate its world position based on its parent's world position.
So for those child particles, so sort of making a child particle, does the renderer need to be aware of the fact that they're children of the parent, or are they extracted out into a single geometry buffer?
I'm coming to the geometry problem, so so this is the last bit on that allocation strategy. The main rule is no runtime memory allocation. There are two global free lists at the moment. One of them is used for the allocation of entities, and one of them is used for the allocation of effect instances. And as you saw with the entities, it manages the entities like within an effect in blocks anyway. So those blocks basically come directly from the global free list. The geometry buffers are allocated from the second global free list. The total allocated memory is basically configurable in that you can say how many entities you want per block and how big you want the blocks to be. And then you can also say how big you want the geometry buffer blocks to be. An exception to this is the way the effect templates are currently loaded. I'm not sure yet if I'm going to change that or not. But basically when you load an effect template, it does a heap allocation and copies the memory that is loaded from the file into heap memory. But so long as you don't load any effect templates at runtime, there won't be any runtime memory allocation. The memory allocation can actually be completely overridden anyway. I mean, you can't change the way the free lists work, but you can basically plug in your own malloc info. So this diagram sort of attempt to show you how the interpreter works. Each entity type has its own bytecode, and in fact each effect type has its own bytecode as well. The interpreter basically works its way along each entity block, and so for each entity it executes the bytecode. In the bytecode will be like operations to load and write back to entity storage, which is in that entity data array. So, there might be like, in the update, it might be creating like a color animation, something like that, storing that into a variable in the entity storage. And during the render pass, basically it's going to come back and it's going to be generating geometry into the geometry buffer. Again, basically having access to the entity data and running the bytecode. But it'll be running a separate block of bytecode, particularly for the rendering part of the pipeline. And it can extract the data, like if it's done this color animation, it can load the pre-computed value from there and then write it out into like a billboard data structure in the geometry buffer. The way the geometry buffers work is basically there's a hierarchy. You have the whole engine of the root. Under that, there's separate buckets for each render layer. Now, what these are basically is a really simple method of ordering the geometry, and it's completely defined in the editor. So, for any particular billboard or any other bit of geometry, the artist who's creating the effect will specify what layer to render it in, and then the engine basically, when it's doing the rendering pass, it's going to traverse these in order, and they come out to the renderer at the other end in the correct order. Under that is material buffers. So basically this is a very simple material sorting strategy. The runtime, by the way, doesn't have any really idea what a material is, because as far as the runtime is concerned, the material is a void pointer that's been loaded over. And it uses that to distinguish them apart from each other and create these buckets. And so ultimately, the geometry is going to come out in material order as well. So there shouldn't be any kind of sorting to do in the renderer. Under each material bucket is a linked list of these geometry buffers. And all they are basically is like, it's like sort of a mini bytecode language itself. It's got instructions to set the material, set the render layout, an instruction to the billboard, a set of instructions for building a trail. And it's really simple data structures. Like the billboard comes through as like a position, a color, UVs, this kind of thing. And so all you need to do is actually in the renderer is to generate the triangles and push them into your vertex buffer. Is there any questions on that before I sort of move on to having a look at how you integrate the code? I can give you a quick look at the how the geometry buffers are processed as well after this. So this is how you set it up. Basically, you can set up this in the initial configuration, and after that you can kind of like override some of the defaults, like how much memory you want to be allocated to that component. You bind in your own renderer. I'm going to come back to that in a minute. You call fx and in, passing in your config objects, and a void pointer to your renderer, and you get back an fx engine. So then your game runs, you do all stuff with the effects, and at the end when you shut it down, it's just this simple call. Now, loading an effect. Firstly, you load the effect template. You're going to pass in your reference to your engine, and basically just a char star that's still tells it where to load the file. You can also load these things from memory, so if you wanted to actually bake the data into memory in your game, you could load them from memory instead of the file. The next call is to load the resources. So what this basically does is involves callouts to the renderer to load textures and materials. Then when you want to create an instance of it, there's fx create instance, you pass in the template, and you get back an instance then and you're ready to basically update and render the effect. When you're done with it, you destroy the instance. So this instance, obviously, you can create as many instances as you want from one template. Unload your external resources, and finally, unload the template. Now, updating and rendering. Basically, before you update any of your instances, you want to call fx begin update. Basically, there's some housekeeping duties and stuff inside the runtime that it does, and also things like keeping track of how long it takes to do certain things and maintaining performance statistics. And then for each instance, you're going to call fx update, passing the instance, passing in the elapsed time. A similar sort of thing for rendering, so you call this function to begin the rendering, and then fx render to render each instance. Now this doesn't necessarily mean that it actually gets pushed out to the graphics API at this point, because as you saw with the buffers, it's basically going to be buffering until you've either finished rendering everything, in which case you'll call fx render and that'll flush the geometry buffers out to the renderer. Otherwise, if it runs out of memory that's been pre-allocated for like midstream, it's going to do its best and basically push out as much geometry as it needs to make space in the correct order. Is that all pretty straightforward? This is the back to the render interface now. So binding in the renderer basically is just a case of plugging in function pointers for loading and unloading textures and materials, flushing the geometry buffer, and basically one for rendering a 3D line, which is used by the runtime for debugging purposes. I'll have a quick look at how this flush geometry buffer function would work in some of my example code. Okay, so basically this is the function that takes geometry buffer, and it's basically just a byte array, and you get the size of it, and you'll do like a while loop until the end of that buffer. The first thing should be a geometry command, which is a meetup, and basically you just switch on that and you've got set material, camera facing billboard 2D. But this is one to start a trail, and then once you've started the trail, there's one for adding points to it. And so basically all I'm doing for all of these is basically the buffer that's coming in basically casting into a structure that has all the data in about the thing that you want to generate geometry for and render. Change between DirectX and OpenGL. But this whole function here is basically user code. It's not part of InsaneFX. It's part of the glue layer between InsaneFX and your renderer. So you kind of write this any way you want. I've got some special sort of debugging stuff here that basically, if geometry disassembly is enabled, it basically dumps out a text stream of what that geometry is. But as an example of something that would be in here, look at the billboard structure. So here basically it's interpreting the billboard command and pulling this billboard structure out of the buffer. And in the future, I'd like to provide different types of billboards to, for when all the features aren't being used, but at the moment they're all in one, and it's got position, width and height, color and alpha, rotation, UV scale and offset, and its direction and whether or not it's going to be aligned. So then basically you need to sort of handle that in your renderer and then convert it into whatever geometry is appropriate for your platform. This is getting close to the end now. There's a few more slides that I'm not going to go over, but I'll put them online in case anyone wants to look at it. Basically, there's my development environment. I'll talk about my test environment briefly because that's one area I'm pretty happy with. I've got tons of example effects. I've got a process set up to do batch conversion from SFX format to FX script format. So basically, if I introduce a bug into the editor, it can often be caught by this first batch conversion. The second batch conversion I've got is from FX script to RFX, and that's done by the FX compiler. And that also, like if I put a bug in the compiler, that'll often pick that up. I've got what I call offline effect simulation, which is basically where I run through every single one of the test effects, and without a renderer, I run it through. And I get performance statistics from this and memory statistics. But I also get like a textual dump of the geometry that's generated, which I'll put in my repository. I'm using Mercurial, and basically it allows me to see if I've made any unanticipated behaviour changes in the runtime, because the geometry that's out there, it's all deterministic. So all the random stuff is deterministic, and I have in the test I have it running at fixed frame rate. So I always know if something that's changed I didn't want to. I've also got like an online effect simulation, which basically goes through all my example effects and visually actually runs them, so I can check them visually to see if they're. And like I said, basically all the outputs from all the batch runs and the offline effect simulation is stored in the repository. So whenever I make a change, I can check to see whether anything's gone horribly wrong, which it often does. So I'm not going to go through this because anyone who's experienced will know this, but if you do want to see all the kind of tips I've got and things I've learned from doing this and generally just from the time as a programmer, you can download this from meetup.com and have a look. So current work, it's obviously still a work in progress. I think it's there's a lot there and it's quite usable in what it does. I'm sure if any of you try to use it, you'll definitely probably come up with feature requests. Currently, I'm working on improving the API and optimizing the runtime, and basically figuring out how to get to data. So at the moment I consider this alpha quality. You can get it now at InsaneFX.com. I've been too in the middle of sort of programming it to really kind of figure out what features I think it really needs to get to beta. But I think that's going to be one of the next steps. And hopefully to get more people looking at it and telling me what they want. Future work is going to be shaders, rendered targets, meshes. I'd like to do like procedural stuff, and possibly extensibility features so that you can, it'll be in the future. I'd like it to be more of like a framework for developing an effects system than anything that's prescribed. Like it's also prescribed here at the moment, and the only flexibility is the way that you can combine all the different things together, which I think is a lot. But I think there's a lot more that can be done in terms of programmers being able to extend it easily for their own engines. That's it.
I don't get it.
If a person wants to extend that, like change something, maybe put in a new input process where some values come from and create little graphs, things like that. How much effort would that have to go to?
It's fairly close. The editor is fairly close to being extensible. Like all the nodes are data driven, and they're kind of text files that specify basically C# classes that sort of define how the node works and stuff like that. But the problem is, if you want to make a node or a new kind of animation, you're going to have to add something to the bytecode interpreter. And I'm struggling to think of an efficient way of making that extensible, because you don't want to do you could do something like, say, associate a particular instruction with someone's function point and pull it out to game code to do something, but that would just seem ludicrously expensive within the context of what I'm doing there. So I'm still trying to come up with a way of extending the bytecode basically. Well, one way I thought of doing it actually, but it's a whole other bigger project, is to take the instantiation language and make that sort of like an instance of a behind-the-scenes procedural language. And it's the procedural language that does like all the work kind of thing, like finds how everything works. And then that's maybe how you make your own template for what a billboard does or what a particle does. But that would basically mean making the bytecode a lot lower level. Like at the moment, there's one bytecode instruction for rendering a billboard, and breaking that down into a set of sort of smaller bytecode instructions would probably impact performance. But that's one way I can see that I could do sensibility, and maybe that would be feasible for future platforms. I'm sure.
I've got some more questions, but.
That's one thing I didn't mention actually. The geometry buffers are designed to be multi-threaded, so you can run the runtime. It should all be thread safe in terms of engines, so you could possibly run different runtimes in different threads. But the geometry buffer is meant to separate a threaded render from the. So basically, the runtime generates the geometry buffer and passes that to another thread, which is going to be rendering. But I haven't tested that yet. That's one thing I should have put on the future work list.
I actually thought about that when you were talking about it sounded like the data was touched to update the particle, and then later on pass over the data again to generate the geometry buffer. Is that right? So that's two phases. Because I sort of heard that now. Would that mean in terms of the whole page coherency data stuff like that?
It doesn't actually quite work that way at the moment. There is some stuff that is timing dependent and has to be done in the update, like physics. But things like color animations that are only dependent on the particle's current time are actually done at the moment in the render phase. So it's not. So some things work that way, and they're stored, like the position and the velocity and the direction and stuff like that are all updated as part of the update and then used again in the render. But things like at the moment, simple animations and even random numbers, because each entity has like a seed associated with it that it could use to recalculate its random values every render. But I'm not quite sure where that's going to go yet in the future. It's a big concern, like breaking up the data, figuring out how to break up the data so that we can touch it as little as possible and making the data that we use in any particular pass, making it as small as possible to make it more cache friendly.
Yeah, so the application of pulling in data using
Something that's on my mind, but it doesn't. The only way it deals with the cache at the moment is to have the data in an array. It doesn't actually separate the data out within something I want to look at.
I actually had that same thought actually when I saw your data structure showed the geometry that I noticed it wasn't aligned. So with your bytecode stuff, you're not using SID registers or vector registers.
There's nothing like that. But that's a potential optimization.
I also wanted to
The data cache optimization is probably the most interesting part of it for me at the moment. That's sort of what I'm concentrating on. But it's hard to make progress. You've only got a couple of hours a week to work on it.
Have you thought about GPU processing, or if that would be possible?
Yeah, I've got all sorts of thoughts on that rumbling around the back of my head. If you fancy working on it, you can join up. It's always forge. I'd love to have other people working on it and experimenting with stuff like that. Does work.